I'm Stuart Gregson. I'm an antenna engineer, and I've had a long-standing interest in measuring things and teaching. I've worked in the antennas and the antenna measurement field for over 25 years now, working in the space, aerospace, and telecommunications sector. So, in the modern world, communications and moving information from one place to another is massively important. And the antenna is really the thing that allows us to do that without being tethered. They allow us, therefore, to communicate across very large distances and while we're on the move. So you find them in phones and tablets and laptops, satellites, aeroplanes, and cars. So the measurement is really the thing that allows us to verify that the antenna works as desired. It allows us to prove out our designs and verify our theories, as well as to demonstrate performance, which is something that's very important, as engineering is a practical but also a commercial discipline. So it allows us to verify for a contract that the antenna that we've designed and manufactured works as intended. So the course that we are planning is online but live interactive course, which I hope will have something for everybody. We start with the basics, with what the properties of the antennas are, before we look at ways in which we can make our measurements. In this, we then develop the planar near field to far field transformation. But when we do that, we take a measurement approach. So we look at a lot of the practicalities. We look at how you'd actually make a measurement. We look at what the uncertainties are and how to compile an uncertainty budget. We take a look at the sort of probes that you would use for acquiring different antennas. We deal with coordinate systems and polarization bases, which are key to this discipline. We also then look at the topic of measuring gain. So gain and efficiency is a very important parameter to antenna engineers and the systems engineers that use those antennas. We then move on and look at some of the advanced topics. We look at things like non-canonical acquisitions, reflection suppression, and phase retrieval. And then finally, in the last talk of the course, we really look at where things are going, and there is where we touch upon technologies like AI and sparse sampling. I hope that technicians, engineers, researchers would all get something from it, and hopefully even the experts might see something presented in a way that they perhaps haven't seen before. It's designed to work with the textbooks, but it presents the material in a very visual way, which I hope makes it as accessible as possible to as wide an audience as possible.